with rectifications, we lose half of the energy or half of the current, right? Because half of the current has been cut off by the diode. So that is not a very good, even though we successfully to convert alternating currents to direct currents, okay? But that is not a very good method, right? Because we lose half of the energy, okay? So we are not satisfied with that, okay? So then we change a little bit on the design and try to keep all the currents in the circuit, and then we come up with these things. Okay, we come up with these things, and this is called rectification bridge. Okay, a rectifier bridge. Okay, so a rectifier bridge. Now first, this alternating current supply, right? Okay, first let's say is clockwise. Okay, clockwise. So clockwise, the current flow up, go to the left. Go to the right. Go to the right. Go down. Okay. So now it come to junction here. Okay, or the first branch here. So it can either go to the left or go to the right. Okay. So what do you all think? It will go to the left or go to the right? Yes, okay, yes, it will go to the right. Why? Because going to the right is forward bias and going to the left is reverse bias. Okay, reverse bias, the currents cannot pass through. Okay, so it will go to the right. Okay, it will go to the right, pass through the diode, the right again, go down, and then go to the left. Okay, okay, and go up. Okay, now I will explain to you what is this. Okay, so in the circuit, okay, if we draw something like this, okay, then it means that this wire is connected to this wire, connected to this wire, and connected to this wire. Okay, it's connected to all three wires. But if we draw a small curve here, it indicates that this wire is not connected to this two. These two just move over, okay, over this wire, and it's not connected to this wire. So the currents cannot go here, okay, because it's not connected. So it will go up. Okay, now it come to the second junction, so second branch here, okay. So it can either go up or go down. So what do you all think? Do you all think it will go up or go down? Okay, let me tell you the answer, okay. It will go down. It will go down. Reason is the current flow from a higher potential to a lower potential. Let's say initially this is 2 volt. The potential 2 volt, 2 volt, 2 volt here, okay, 2 volt, okay. Now after passes through the resistor, the potential will drop to 0 volt, 0 volt, 0 volt, 0 volt. Here also 0 volt, 0 volt, 0 volt, 0 volt. When you go to this part, this path, okay, is 0 volt, and if you go up, okay, it will go to a 2 volt. But as I told you just now, the currents move from higher potential to lower potential. So 0 volt cannot go to 2 volt because here the potential is higher than here. So it cannot go up. Okay, it can only go down and back to this alternating current source. So that is the flow of the currents when it's forward bias. Okay, when it's forward bias, let me erase this. Okay, so and then it go here, and go here. Okay, now if you draw the graph, okay, or if you connect this to the cathode ray oscilloscope, you connect this to a CRO, you will get something like this. Okay, you get something like this. The current increase, decrease. Okay, increase, decrease. If the cathode ray oscilloscope connect here, because it flow clockwise, the current increase, decrease, you get something like this. Okay, then when the current move backwards, anti-clockwise, let me use another color for this to show the difference. Okay, so anti-clockwise, the current go down, the current go down, and so we'll go here, go here, go here, go here. Okay, now up to this point, it will go to the right or left. Right means it go up, left means it go here, okay? Right, it will go to the right, it move to the right. Why? Because it's forward bias. It's forward bias. forward bias. Okay, forward bias. Okay, forward bias. When it comes to this point, it will go up or go down. Yes, when it comes to this point, it will go up. Why? Because go down, then it will go back to the higher potential, right? Okay, so it must go up. It cannot go back to the initial path because the initial path, the potential is higher. Okay, so it must go up. So it go up. Okay. Okay, back to the alternating current source, right? Okay. Let's see. Here you can see that the currents move in two directions, right? Here move forward, here move backward. Here also backward, forward. Okay. But how about this area from this point onwards to this? So we can see that the currents move in the same directions, right? Whether it move forward or it move backwards, clockwise or anti-clockwise, the current here always move in the same directions. Okay, you see the blue one, okay, clockwise. The orange one is also clockwise. So the current here move in one direction. If you connect this to a cathode ray oscilloscope, you will find that the current is like this. Okay, so you see the currents always move in the same direction here. So means that this rectifier bridge successfully convert alternating currents to direct current. So now it's a direct current because the current always flow in one direction. And then you see no current loose in the process. Unlike this half wave rectification, 50% of the energy loose to the this one no energy loose, 100% of the currents remained in the circuit. Okay, and we call this full wave rectifications. Okay, by using this rectifier bridge, we can do full wave rectifications where we change alternating currents to direct currents. Okay, all the current here is a direct currents. Okay, it's a direct currents, and then some no currents loose in the circuit. So this is a full wave rectifications. Okay, and again it's not steady, increase decrease increase decrease. Okay, so if you want to make it steady, then you connect a capacitor parallel to the this resistor. Now this resistor usually is representing a bulb or something like that. Okay, a bulb or any electrical appliances. So connect a capacitor, then you can make it smooth. Okay, you can make it smooth, and it will be something like this. So the currents will be something like this. Let's erase the previous one. Okay, so after connected to the capacitor, then you have a smooth, steady current. So this is full wave rectifications. So by using this rectifier bridge, we can convert alternating currents to direct current and no energy loss to the surroundings, and you will get something like this, full wave rectifications. Okay, another way to do full wave rectification is by using a transformer with two diode. Okay, it's like this. Now for this bridge rectifier, you need to know how to draw this. Okay, because in exam they may leave this blank and then they would like you to draw this. Okay, so you must know how to draw this. So for examples, they may give you something like this. So they say, okay, so complete the circuit, okay, to show how a full wave rectifications can be done. Then you have to draw. You have to draw the bridge rectifier here. You have to draw the bridge rectifier here. So how to draw? Okay, so first, okay, we go down here. So we start from here. Okay, we start from here. Both pointing out. Okay, and then both pointing in. Okay, these two point out, these two point in. Okay, so then we draw. Then you can draw the circle. Okay, draw the circle. Okay, then we complete the circuit. This one go up, it go here. Okay, after go here, then it will go to the capacitor. Let's erase this a little bit here. Okay, let's erase this. Okay. The connection is not correct. So you go to the center. Okay, so you see from the center here, go to the center. Okay, then after that it come out from here and draw a small curve here and go in. So that's how we draw the bridge rectifier here. Okay, how to draw the bridge rectifier here, because in the exam they may ask you to draw this, so make sure that you know how to draw this, and try to practice. Take out a piece of paper and try to practice on how to draw this. Sometime, okay, you may also ask to draw this. Okay, so if you have a transformer, this is a transformer, then you only need two diode, okay, so one up, one down. Let's say when it's clockwise, this is positive, this is negative, clockwise. Okay, so the current flow here, go here, then it will go here, because here is reverse bias, so the current won't go. Okay, so it go here and then go down. Okay, and up to this point, okay, the current will go to the earth. The current will go to the earth, or if you don't have this, then the current will go up. Okay, but if you have the earth here, then it will go to the earth. Okay, so see the current here, it moves downwards. Okay, move downwards, and then when it move in the opposite directions, counterclockwise. Okay, now counterclockwise, this is positive, this is negative. Okay, and this is also positive. Okay, okay, positive. Maybe this is 2 volt, this is 1 volt, and this is 0 volt. Okay, 0 volt, and current move from higher potential to lower potential. Higher potential to lower potential. Sorry, I think I drew it wrongly. Counterclockwise, okay, counterclockwise means that this is positive, this is negative. Okay, so maybe this here 2 volt, here 1 volt, here 0 volt. Here 0 volt. Okay, so the current will move here. Okay, go here, go here, go here. Now up to this point, it will go to the left. Why? Because go up is reverse bias, so it won't go up. So and then you go down and move to the earth. Go to the earth. So you see whether it's clockwise or anti-clockwise, here the currents always flows in the same directions, right? Okay, always flow in the same directions, and therefore you will get a full wave rectifications. So that is another design to do the full wave rectifications. The first one is bridge rectifier with 4 diode. This one, bridge rectifier with 4 diode, and the second one is a transformer with 2 diode. Okay, both of these can do full wave rectifications. Okay, both cases you must know the directions of the current, the flows of the currents through the whole circuit. You must know how it flow. Okay, you must know how it flow, especially this one. Okay, you must know how the current flow. Okay, the currents here come here and then it will go down here and then go to the resistor and go down. Okay, let me show you it again. Okay, so you must know that the current flow here, go down. Okay, okay, and then it move back, okay, go up. So you must know how it flow. Okay, because in the exam this may be asked. This may be asked, and you need to know that from this point to this point is direct current, but for the other parts of the circuit is still alternating currents. The current move backward, forward, but from this point to this point is direct current. Okay.